Hello everyone, welcome to another session, and in this session we will discuss various operations on data frame such as Boolean indexing, filtering data, creating and resetting indices, renaming rows and columns, and iteration. Let's explore how to manipulate and analyze data efficiently in Pandas. The topics which we are going to cover in today's session are Boolean indexing, filtering data, creating, changing and resetting index, deleting rows and columns, renaming rows and columns, retrieving using head and tail functions, binary operations in Pandas DataFrame, iteration. First one is Boolean indexing. Boolean indexing is used to filter data by selecting a subset of the data from a given data frame. From that given data frame, a subset of that data frame can be selected, can be filtered by using Boolean indexing. The subsets are chosen based on the actual values. We apply some conditions and based on that condition, data will be chosen. That's what actual values of the data in the data frame, and note their row or column labels. Usually we select a part of the data frame, that is a subset of the data frame, by passing row or column labels, right? But Boolean indexing is filtering data by selecting subsets of the data by using the actual values of the data, by applying some conditions on the data. But if you explicitly want to set the index of a data frame to Boolean values, you can do that. Like this. Here a data frame is created. This is the data, that is a dictionary of list. Which are the different column names here? When we create a data frame by passing dictionary of list, which are the different column names? Name, job, age. The keys of the dictionaries will be the column names. And how many rows will be there? How many elements are there in the list? Those many. Rachel, Monica, Joy, Phoebe. So here we will have 4 rows. So the data frame will be created. So when we create the data frame, we are passing these Boolean values as the index of the data frame, row index of the data frame. And how to fetch the data? Print df.log. We can pass the Boolean values true or false to fetch the data. But Boolean indexing is filtering data from the data frame using some conditions. So we can use Boolean indexing to filter the data using conditions on column names, index names, etc. To display the data of students if the total is greater than 250. So this is our mask. This is the condition. Import pandas as PD. We have created the data frame by passing again a dictionary of list, name, age, city. These are the column names. See here you can see name, age, city, and which are the how many rows are there? We have 4 values here, so 4 different rows are there. And we haven't passed any data, any index here, right? See, we have just passed the data. So by default the index will be 0, 1, 2, 3. This is our data frame. Now see this command, print df, then in the square bracket df of age greater than 30. So if you want to filter all the columns, that is df based on this condition, that is df of age greater than 30. df of age, which column will be fetched? This one, age column, right? That is our condition, df of age greater than 30. Now what we need to fetch? Based on this condition, what we need to fetch? Data from the data frame. That's what this df. df, then in the square bracket, df of age greater than 30. So when we pass the condition, what will happen? See, for the first one, for the first row, 0 June 32, New York, age is 32, which is greater than 30. So true value will be passed. So if it passed true value, the Boolean value true, that will be fetched. For the second one, it is 28 greater than 30. No, that is false. So the false value will be passed, that will not be fetched. Next one, 35, that is greater than 30. So what will be passed? True value, right? So that will be fetched. Again, true. So which all rows will be fetched? 0th, 2nd and 3rd. 0, 2 and 3. See, this is same as this one. When we pass inside the log function, if we pass the index as true, false, see, it is passed as a list. Using log function, we can access rows, right? If we pass true, false, the false value will not be fetched. Only true values will be fetched here. 0, 2, 3. So here that is happening. df of age greater than 30. What will be fetched? The age will be compared. df of age, the values in the column age 32, 28, 35, 40. The condition will be tested and true or false value will be returned. Using conditions on column names, or index names to filter data values to display the data of student if the total is greater than 250. This is the data frame. Here we have 4 different columns: math, science, English and total, and 4 different rows: Alan, Priya, Ram and Sheetal. These are the rows and columns. Print df data frame, then df of total greater than 250. What will be the output? Df, we need to fetch the data from df. That's what the first df is. Then inside the square bracket we pass the condition. That is df of total greater than 250. df of total, this field will be fetched. The last column will be fetched. And we compare the values in the column with 250. First one, 248 greater than 250. What will be passed? False will be passed. So it will not be fetched. Next 262. Yeah, true. That will be fetched. 264. Yes. That will be fetched. 223. No. So what will be the output? The second and third one, Priya and Ram. The rows, the values in the rows, Priya and Ram. Right. Now next, to display the total marks of students who scored more than 70 in math. So here what we need to display? Total marks of the student. Here the data of the student we had to display, right? Here the data of students we had to display. That is the whole data frame, whole data. Here what? Total mark of the student. So that we have to fetch first. How to fetch the total mark of students? df of total mark. df, then in the square bracket, total mark. That is how we fetch a column. To access a column, we have to pass the column name inside the square bracket. df of total mark. Then open the square bracket and pass the condition. What is the condition here? Scored more than 70 in math. That is df of math greater than 70. See. df of total. Here the df of total. Here it was only df. Here it is the df of total because we need to fetch only the values in the total column. Then we pass the condition inside the square bracket. df of math greater than 70. So it will check the column math, right? With each value the condition will be tested, and for the true values what will be returned? Not the full data, only the column total. See the first one. First one is 75, which is greater than 70. So that will be returned. 248. The index, row index and the total 248. Other columns are not there because here we have df of total. Right. Now for the second one it is 80. That is also true. So 262 will be returned. Then 95. That is also true. Again 264 will be returned. Then we have 65. Now this is false. So false will be, Boolean false will be returned. 223 will not be displayed. This is our output. Next is creating, changing and resetting index. How to create, change and reset the index. We will create a data frame now. df equal pd dot data frame function is used to create a data frame, right? Now open and close the bracket. Here I am going to pass a dictionary of list. So it's a dictionary and values are list. First key is A, values 1, 2, 3, 4, comma, next key value pair, that is B, colon, 10, 20, 30, 40. So this is my data frame. This is the data frame. Here the indices are 0, 1, 2, 3. Now if I want to change the index, how to change? We can use df.index. This is how we access the index, but we can initialize the values. How many indices are there? 4. So you have to pass exactly 4, otherwise it will throw error. So here I will pass x, y, c, s. Now when I print data frame df, what is the index? x, y, z, c. x, y, z, s. These are the index. That's what creating index. The index can be customized using set index or reset to default with reset index. Now we can use this function set index or reset index. Set index is used to set a particular column as the index. If we want to set a particular column as the index, we use set index. Now to reset it, we use reset index so that it will be reset to the default, the positional index 0, 1, 2, etc. Now, how to use the setIndex function df.setIndex name in place equal to true. We use in place equal to true to change the original data frame. Okay, to change the original data frame, we pass this in place equal to true. In place argument is used to change the original data frame. If we don't pass in place argument, what will happen? A new data frame will be created. The original will not be changed. So, when we print the data frame, here in this data frame, which are the row index 0, 1, 2, right? Now, when we set the index to name, what is the new data frame? See, the name, that is the index now. Name column is the index, and you can see a name for the index as well. Name. Amit, Neha, Rash, they are the index now. So, using set index, we can set a column as the index. Now, next is resetting index. See how to use reset. The data frame name dot reset index. Then we pass in place equal to true. See the output. Again, the name became a column in the data frame. And what is the row index? 0, 1, 2, the default index. Reset index replaces the default integers 0, 1, 2, 3 as the index value. So that is resetting index, setting and resetting index. Next, deleting rows and columns from a data frame in Pandas. How to delete rows and columns from a data frame. Pandas provides the drop function to delete rows and columns from a data frame. You can delete single or multiple rows or columns depending on your requirement. So we have created a data frame here. Which are the column names? Name, age and city. Right. How many rows are there in the data frame? 2. Name, age, city, and we have created the data frame. Now, first is deleting rows. So which function is used to delete a row or a column? We use drop function to delete a row or a column. Rows are identified by their index labels. To delete a row, specify the index and set axis equal to 0. We have to pass axis argument to the drop function if that is a row. But by default, the value of axis is 0. So we don't have to pass axis equal to 0 if we are going to delete a row. But if you are going to delete a column, we need to set the axis equal to 1. Okay. So here df.drop 1. See, we have an index 1 here. Axis equal to 0. But here this is not mandatory because by default the value of axis equal to 0. So we can just pass df.drop of 1. Open the bracket, write 1, close the bracket. That is also correct. Now when we use df.drop of 1, what will happen? It will return another data frame. A new data frame will be returned without the index 1. In that new data frame, we have only 0, 8, 20x. Now, if you want to delete the index 1 from the original data frame, we have to pass in place equal to true. Here, see here, I am going to delete the row x. df.drop. What should I pass? X, right? Now see the new data frame. Do we have x here? No. We have only y, z and s. Now I am going to print the original data frame df. See here x is there. That means original data frame is not changed. It will return a new data frame. I am going to use df.drop of x and comma this argument. What is that? In place equal to true. By default the value of in place is false. So if you want to delete the original data frame, you have to, the index from the original data frame, you have to pass in place equal to true. Okay, new one is not created now. When I print df, see the original data frame has changed. That is the difference. So here axis equal to 0 refers to rows. If we need to delete the row, the axis equal to 0, but by default the value of axis is 0. In place equal to true. If true, makes changes to the original data frame. Now you can delete multiple rows or columns by passing a list. We know to access rows or columns, also we pass it as a list. Here for deleting, we can pass it as a list. See df.drop, then inside the drop function you pass it as a list. 0, 1, access equal to 0. Now what will happen? An original data frame will be created and it will be empty because we have only 0 and 1 and we are deleting it. The original data frame remains unchanged. Next, deleting columns. Next is deleting columns. Columns are identified by their column labels. To delete a column, specify the column index and set access equal to 1. So df.drop, here the columns are name, age, city. If I want to delete the column age, pass the column age inside the drop function. And here you have to pass access equal to 1. Okay, otherwise it will not be deleted. You have to pass access equal to 1. Now what will happen? A new data frame will be created, right? What about the original data frame? That will not be changed. If you want to change the original data frame, we have to pass in place equal to true. So access equal to 1 refers to columns. Access equal to 0 refers rows. In place equal to true, if true, makes changes to original data frame. You can delete multiple columns by passing a list of column labels. See, if you want to delete 2 columns, for example, age and city, you have to pass it as a list. Inside the list square bracket, age, city. What will happen? A new data frame will be created without age and city. Only name column will be there. Now, what about the original data frame? No change because we didn't pass in place equal to true here, right? So this is how we delete rows or columns in data frame. We use drop function. Along with drop function, we have to use access. If it is row, access equal to 0. If it is column, access equal to 1. Then to change the original data frame, we need to pass in place equal to true. Next, del and pop function to delete a column. To delete a column, we can use this del and pop function as well. In dictionary, we learned, right? Del and pop function. So del, how to use del function? First it is del, then df of pass the index. Pass the column index. This will be deleted. Next, pop. How to use pop? Data frame object dot pop, then pass the column index. But usually we use drop function to delete a row or a column from a data frame. Next is renaming rows and columns. Pandas provides the rename function to rename rows and columns of a data frame. You can rename specific rows or columns without modifying the original data frame by default or make changes in place. How to do that? By using in place. Here, this is our data frame. We have 3 columns and 3 rows here. First is renaming columns. You can rename one or more columns using the columns parameter in the rename method. See the format. Inside to the rename function, we have to pass a dictionary. We will pass a dictionary as the value of the columns argument. See here data frame name. This data frame is data frame name dot rename. Then open the bracket. Columns equal to the value is a dictionary. And what about the key and value? Keys and values of the dictionary. Keys are the old column name. Values are the new column name. Now what is this in place equal to false? By default in place equal to false, so no need to pass it. If you want to change the original data frame, we need to pass in place equal to true. Right. See here the example. I want to change this column name math to mathematics. How to change? We use rename function. Inside the rename function, what has to be passed? Columns. Columns argument. What is the value of columns argument? That is a dictionary. In the dictionary, the key is the old name. Value is the new name. See, df.rename equal to df.rename. This is how we change the column name. df.rename. Then pass the argument columns equal to a dictionary. What is the key? The old column name math. What is the value? The new column name. So when we execute this command, what will happen? A new data frame will be created. That's why we stored it in df underscore renamed. Here we don't pass in place equal to true, right? So what will happen? The original data frame will not be changed. A new data frame will be created. So the new data frame is stored in df.renamed. Now renaming multiple columns. If you want to rename multiple columns, here inside the dictionary we can have many keys and values. The keys are the old column names, values are the new column names. Here I want to change math to mathematics and science to physics. So how to do? df dot rename, then we pass columns equal to, the value of the columns argument is a dictionary, right? 2 key value pairs are there. If we want to change 2 column names, we'll have 2 key value pairs. Math, that is the old name. New name, mathematics. So math will be changed to mathematics. Next, science, that is the key. Physics is the value. So science will be changed to physics. Okay, here also we didn't pass in place equal to true. That's why we are storing it in a data frame. A new data frame will be created and it will be stored in df renamed underscore multi. Now, here see this one. Here also we are changing the column names math and science. Math to mathematics and science to physics. df dot rename. Here we are not storing it to any data frame because nothing will be created here. The original data frame will be changed. df dot rename. Then columns is passed. What is the value of column? A dictionary. And which are the keys of the dictionary? The old column names math and science. Math and science. Which are the values? The new names mathematics, physics. Here in place equal to true is passed. So what will happen? It will change the original data frame. Next is renaming rows. How to rename rows? For renaming rows also we use which function? Rename function. You can rename one or more rows using the index parameter in the rename function. But here we pass index. For renaming columns we pass columns, right, inside the rename function. Here to rename the index we pass index. To rename the rows we pass index. What is the format? Data frame name dot rename. Then we pass index. Now what is the value of the index? That is also a dictionary. The keys, they are the old row names. Values are the new row names. In place equal to false. So here if we want to change the S1, the row label S1 to student 1, we use rename function. See df dot rename, then we pass index. As we need to change the row, we pass index argument. What is the value? A dictionary. The key is the old name S1. Value is the new name student 1. Now if we want to change more than one row name, we have to pass more key value pairs. See df dot rename index equal to, that is a dictionary. Which are the keys of the dictionary? S2 and S3. The values are student 2 and student 3. So S2 is replaced by S2 by student 2 and S3 is replaced by student 3. Now if here a new data frame is created. Why? Because we haven't passed in place equal to true, right? Now if we need to change the original data frame, we have to pass in place equal to true. That's how we change rows and columns, row names and column names of a data frame. Now renaming rows and columns simultaneously. How to rename it together? We use rename function. See, inside the rename function, you pass the columns and index attribute. First two attributes are there, columns and index. The values of column is the dictionary with keys as old names, values as new names. Then index attribute. Value is a dictionary with keys as the old names and values as a new name. That's it. We will have two arguments if we need to pass rows and columns together. The arguments are columns and index. Next, retrieve using head and tail function. How to retrieve the rows of a data frame by using head and tail function. In series, we have learned head and tail function. What is that? It is used to retrieve the first elements or the last elements. Head, first elements, tail, last elements from the series. Right? If we don't pass any number inside, by default, it is 5. The first 5 or the last 5 will be retrieved. Here also the same thing. By default, it retrieves 5 top or 5 bottom rows respectively of a data frame object. Now what is the format? Data frame dot head n equal to number of rows, or data frame dot tail n equal to number of rows. Example, df dot head n equal to 2, or df dot head, we can just pass 2 also. No need to write n equal to 2, we can just pass 2. Tail, same as series. Head function returns the first n elements, first n rows. Tail function returns the last n rows. Here n equal to 2 or df dot tail of 2, what will be returned? The index S2 and S3, right? Math, Science, English, then S2, S3. The data of S2 and S3 will be returned 80, 75, 78, 70, 95, 8. That's it. Now next is binary operations in Pandas data frame. Binary operations in Pandas involve performing element-wise operations between two data frames or a data frame and a scalar value. Either data frame, two data frames in between two mathematical operations in between two data frames, or a data frame and a scalar value like df plus 10. Then each data in the data frame will be added by 10. These operations include addition, subtraction, multiplication, division and other similar operations. So first one is addition. I've created a data frame, two data frames here, df1 and df2. See, first one a and b is the index, second one also a and b, the values are different. So this is the first data frame, this is the second data frame. Now when we add these two data frame by passing plus function, what will happen? At each index the values will be added. First it will check whether matching indices are there or not. If matching indices are there, then it will be added. Here we have the same index, column index and row index. So what will happen? 1 plus, at a and 0 we have 1 and 10. 1 plus 10, 11. B, 3 and 30. So 3 plus 30, 33. Then at a and 1 we have 2 and 20. So 22. At 1 and b we have 4 and 40. So 4 plus 40, 44. Now the result will be same if you execute this add function, df1 dot add of df2. df1 plus df2 is same as df1 dot add of df2. We will get the same result. Now here see data frame 1 we have a, b as the columns. Data frame 2 we have a, b, c as the columns. So here we have different index, right? Now what will happen when we add? If we don't have matching index there, it will be NaN values. Right. Here also we can use fill value. As in series, we can use the argument fill value. If we give fill value equal to 0, here in the first one C, that is not there. So the value of C will be considered as 0. 1133. Now 100 plus 0, 100. Then 2244, 200 plus 0, 200. That is fill value. Next is subtraction or sub. Here also we have created two data frames, df1 minus df2. At each index it will be subtracted. That's it. 1 minus 10 minus 10. Minus 9. 3 minus 30 minus 27. See, 2 minus 20 minus 18. 4 minus 40 minus 36. And you have to give the same column labels and row labels. And it is same as df1 dot sub of df2. We can use sub function as well. Next, multiplication or mul function. Two data frames are there. When we multiply, what will happen? At each index, the values will be multiplied. 1 into 10, 10. 3 into 30, 90. 2 into 20, 40. 4 into 40, 160. Same as df1 dot mul of df2. Next is diff function. When we divide two data frame, if we have same index, the division will take place. See. Same as df1 dot div of df2. Now here our data frame is, this is our data frame. If I write df plus 10, what will be the output? See, at each value 10 is added. That's what we can add a data frame with a scalar value. At each value the scalar value will be added. Next is comparisons of Pandas object. See, equal to operator. Test two objects for equality with non-NaN in corresponding locations treated as equal. Returns true if equal and returns false for NaN values. Next is comparisons of Pandas object. First one is equal to. Test two objects for equality with non-NaN in corresponding locations treated as equal. Returns true if they are equal and returns false for NaN values. If other values are equal and if you have NaN values at the same position in both the data frame, then also it will return false. See this data frame, df1, a12, b34, df2. Same data frame, right? df1 and df2 are same. So what will be the output of df1 equal to df2? At each index it will return true. Equal to operator will return Boolean values at each index. Now see here, df1 this is the data frame 1, 2, 3, then the next value is nan. Here df2 is also the same data frame, right? But for nan values, it will return false. So at 0 and a it will be true, 0 and b it will be true, 1 and a it will be true, but 1 and b it will be false. See, that's it. Now if we use equals function, test two objects for equality with nan in corresponding locations treated as equal. Here it will return, if both the data frames are same, it will just return true. Not at each index, but only the Boolean value true or false. And for nan values also it will return true. See, we have two data frame, same data frame, df1 equals df2. What will be returned? True. Now df1 and df2, they are also same data frame. Here df1 dot equals of df2. Nan values are treated as equal values and it will return true. So comparing two data frames with different number of rows or two series objects with different lengths will result in value error. So we cannot compare two data frames with different number of rows. Next, iterating over a data frame. What do you mean by iteration? Accessing each value, right? So this is our data frame. Here we have three columns, name, age, city, and two rows, P1 and P2. These are our data, Alan 20x first row, second row Bob 25 y. Now what is iter rows? This method iterates over data frame row wise. Row wise means this one, horizontally. P1 Alan 20x, that is row wise. Each row, where each horizontal subset is in the form of row, index and series. So it iterates over data frame row wise, where each horizontal subset is in the form of row, index, series. So here which are the row index? P1. Now what will be the series? Series is, in series the values are Alan 20x, the index are name, age, city. This is how it will be returned, where series contains all column values for that row index. Items, this method iterates over data frame column wise. Column wise it will iterate, where each vertical subset is in the form of column, index and a series, where series contains all column values for that column index. Now we will see what is iter rows, how to use iter rows. This is our data frame for I, j. Here we have seen what all will be written, row, index and series. That's why we wrote I, j, so that we can access the row, index and the series separately in df. So for I, j, this for loop you know, right? For loop variable, here two variables are there, I and j, because we have two values will be written. One is the row index, second is the series. In operator, then df dot iter rows. Now print I. What will be printed? The row index. The values of I, they are the row index. Print j. What will be printed? The value of j, that is the series. Here how many rows are there? 2. So how many values are there for I and j? 2, right? I values are P1 and P2. J values are, first j is name Alan, age 20, city X. D type is object, that is the first value. Second value of I is P2, J is name Bob, age 25, city Y. See, P1, this is our I, this is the J. Name Alan, age 20, city X. The row wise data will be written as a series and the index are the column labels. P2, name Bob, age 25, city Y. D type is object. Next, df dot items. Same for loop for I, j. Because here also we have the column index. I values will be the column index and j is the series with column values. And row index as the index of the series. So print I. Which are the values of I? Name, age, city. This column index are the values of I here. Print j. What about j? For name it is P1 Alan, P2 Bob. For age it is P1 20, P2 25. For city it is P1 X, P2 Y. See, name P1 and column wise. So when we use items, the values of I, they are column labels. Name, age, city. Name, age, city. Now what about J? That is the values in the column Alan and Bob. And the index will be the row index of the data frame. See, P1 Alan, P2 Bob. D-type object. P1 20, P2 25, D-type in 64. X by D-type object. Now what is the output of the below code based on the data frame? See, this is the data frame. What is the output here? For I, j in df.iter_rows, print j. Here we are printing only j. What is iter rows? When we use iter rows, this will be fetched row wise. Which are the different rows? Delhi, Mumbai, Kolkata and Madras. These are the different rows. So what will be the value of I? The row index. Delhi, Mumbai, Kolkata, Madras. But here we don't have to print the value of I. We have to print only j. So what is first j? 4 times this will be executed, right? Because we have 4 rows here. So 4 times this will be executed. In the first execution, what is the value of j? That is the series which has the first row elements as the values and the column labels as the index. That is hospitals 189.0, schools 7916. That is the first value of j. Second value, hospitals 288.0, schools 8588.0. Next, 149.8, 7225.0. Next, at hospitals it is 9 and for schools it is 7615.0. So that's it. Thank you for watching and I hope you found this video helpful. If you have any questions or any doubts, drop them in the comments below. See you in the next video.